Hello everyone, I welcome you all to Startup Academy, your online gateway to success in ISS exam. This academy is exclusively for ISS exam. We are focusing on ISS 2026 and we have been doing the topic sampling techniques. We have completed econometrics of paper 3 which is of descriptive type, and in sampling techniques we have covered simple random sampling with replacement and without replacement, stratified random sampling and systematic random sampling. Since most of you have asked for PYQs, so we'll be covering two PYQs on stratified random sampling in today's lecture, and afterwards we'll continue with our systematic random sampling. So let us begin. So this is the PYQ of 2025, which is of 15 marks. In this, they have given us a total cost function, which is C naught plus summation Ti Ni, and we have to minimize variance, keeping the cost fixed. So let us say the fixed cost is nothing but summation Ti under root Ni, or we can say that it is nothing but C minus C naught. For this fixed cost, we have done all of this in optimum allocation. If you remember, first we fixed cost, then minimize variance, and then we fixed variance and minimize cost. So here we take Lagrangian form. First of all, we know that variance of y bar st is nothing but summation I goes from 1 to n. Here also I goes from 1 to n. Wi square 1 upon small ni square minus 1 upon capital Ni square. Okay. One upon small ni minus 1 upon capital Ni into capital Si square. So this is the variance of our stratified random sampling. We all know that. And the Lagrange's or Lagrangian function can be written as L, or we can write phi I, anything you can write or denote it as variance of y bar st plus lambda square C minus C naught, or the fixed cost, where C is total cost, C naught is overhead cost, and summation I goes from 1 to n Ci under root Ti under root Ni is the cost of ith stratum, and lambda square here is nothing but Lagrange's multiplier. Okay, so now first of all we'll write it. L is equals to summation I goes from 1 to n Wi square, or let us say it is 1 to k, because n we have taken there, so let us take it as 1 to k. Wi square Si square upon small ni plus lambda square summation I goes from 1 to k Ti under root Ni minus summation I goes from 1 to k Wi square Si square upon capital Ni. Now differentiating this L with respect to Ni, we'll get minus Wi square Si square upon Ni square, and this will be plus lambda square Ti upon 2 under root Ni. And this will be equal to 0 because there is no Ni present. Now we'll put this equal to 0. So we will get what? Wi square Si square upon small ni is equal to lambda square Ti upon 2 under root ni. Now this can be written as ni raised to the power half. Now if we cut this with this is ni square with this, we are left with 3 by 2, and taking ni on one side and rest other on other side. Ni raised to the power 3 by 2 is equals to wi square si square upon ti into 2 upon lambda square. Or we can also say that ni raised to the power 3 by 2 is directly proportional to wi square si square upon ti, taking the constants away. Or we can write it as ni is directly proportional to wi square si square upon ti raised to the power 2 by 3. And this was what we had to prove. This is what we had to prove here. So it was an easy one. I have done just the derivation. You have to write the notations as well. What is Ci means, C naught means, Si, Wi, and everything. And like we did the derivation in the original lecture, you'll do it like that. Now moving on to second question. Here we have been given a function of cost, total cost, and to minimize cost with variance y bar st, we have to prove that nh is directly proportional to whsh under root ch. So again here this was also of 15 marks and it came in the year 2020. So again here we will write C is nothing but total cost. C naught is overhead cost. Summation h goes from 1 to L, CH, NH is nothing but the cost of each stratum, or we can say HH stratum. Okay, now we have to prove it in a similar manner. So let us take the Lagrange's functions. L or phi ni, anything you can take or denote it as variance of y bar st plus lambda square c minus c naught, where lambda square is nothing but Lagrange's multiplier. So variance of y bar st is summation h goes from 1 to k, 1 to L, wh square 1 upon nh minus 1 upon capital NH sh square plus lambda square summation h goes from 1 to L, this is ch and small nh. Now we will differentiate it with respect to ni. So if we'll differentiate it with respect to ni, we will get wh square sh square upon nh square with a minus sign plus lambda square ch This is the thing. So we will put it equal to 0 because this is a normal equation and we have to find the value of Ni or NH. Equal to 0. So it will be WH square SH square upon small nh square is equals to lambda square CH. Now we'll put NH on one side and rest other on other side. NH square is nothing but WH square SH square upon CH into 1 upon lambda square. Taking the constant away and putting the proportionality sign, we will get NH is directly proportional to WH square SH square upon CH, and NH is directly proportional to WH SH upon under root CH, taking the under root on both the sides. So this is what we had to prove in the question. NH is directly proportional to WH SH upon under root CH. This was all for the PYQs of systematic random sampling. This type of PYQs has been asked more often, and somewhere it has also been asked that what do you mean by stratified random sampling, and what is the advantages and disadvantages of stratified random sampling. That we had done in the class, that you can see the lecture videos, you will be clear with the concept of that and you can write it on your own. uh, uh, keep on doing the hard work and keep on working, watching the videos consistently and doing what we do what we are doing in class. Do it at your home as well. All the best. Thank you.